Hello 8th graders, this video is all about 5.2 in our list of ELRs. This is about metals, nonmetals, and metalloids. If you've been wondering why there are these colors on your periodic table, this lesson is going to explain that. Basically, chemists separate our periodic table into 3 different families or groups, and it's all based on how they behave and where they are found on the periodic table. The first thing that you need to do for this lesson is actually go and find some of the facts that you need for this topic. In Google Classroom, there is a digital version of the reading that you need, and there are also paper copies in the classroom. Your job is to use the note paper and these readings in order to fill in the table. The notes look like this. Your job is to, for all 3 of these categories, metals, nonmetals, and metalloids, figure out where they are, what some of their properties are, whether or not they like to gain or lose electrons, and finally, how many valence electrons they can possibly have. Once you are finished gathering those facts and filling in this table, the back side of your notes has a periodic table on it that's all black and white. Your job is to take some highlighters and fill in very carefully, please make sure that you take the time to do these right, fill in the ones that are metals, nonmetals, and metalloids, each with their own color. Personally, I would leave the metals just clear paper because they're the ones that take up the most space and it'll save you the most time. Here's a little caution. Be very cautious about hydrogen. Hydrogen likes to hang out with one group even though it's a member of another. It's like an imposter. Please don't highlight it. Pause this video now and go take care of these steps. Ready, go. If you're still watching, you are ready to check your notes and check your color coding on the back of your notes. On the notes, some things that you need to make sure that you have is that metals are on the left side. They're all the red ones on my screen. You have to imagine that there's a little staircase that starts up at boron and works its way down, down, over, down, over, down, over. And everything to the left, except for a couple of them, we'll talk about those in a second, and hydrogen, these are all metals. Those things are what we call ductile, which means that you can stretch them into wire and they won't snap. So imagine pulling on it really hard and it just stretches out and it doesn't break. They're also malleable, which is similar to ductile. It means that if you hit it with a hammer, it won't shatter. It'll just mush. So think of like hitting a nail and it bending over and not shattering like glass. Metals are also great conductors of heat and electricity. They are typically shiny and they have very high melting points. For me, it's helpful to remember a specific metal that I can think of, like a penny, for example. I can remember that it's shiny. I know that it conducts electricity because that's what wires are made out of. They're made out of copper. I know that when I put pennies on a railroad track, they get crushed by the train and squished and spread out like pancakes. And so that helps me to remember a lot of the things in metals. Now for gaining or losing. This goes back to when we learned about valence electrons. So let's just take any specific one, maybe something like beryllium in the second column. If you remember back to your valence electrons, it has 2. And it really wants to have a full shell. So you have to ask yourself, would it like to lose those 2 electrons and expose the next layer? Or go around and steal 6 electrons to get a full ring? Well, metals, because they don't have very many to start with, they tend to lose electrons. Now the last one, what is the range of their valence electrons? Well, everything from lithium all the way out to polonium, those are all metals. So from 1 all the way out to 5 valence electrons. That's everything under the metals category. Although most metals are just somewhere between 1 and 4. I'll show you more about that in a second. For your nonmetals, it's everything on the right-hand side, and basically their properties are just the opposite of metals. So everything that a metal is, they are the opposite. Just like the opposite thing, they like to gain electrons. So take, for example, fluorine. Fluorine has 7 valence electrons and it really wants 8. It's easier for it to steal 1 more. So they like to gain. The only exception to that are the last column where they already have a full shell. Those are also nonmetals, except that they don't gain or lose anything. They are technically nonmetals though. And then the last bit, they have 4 to 8 valence electrons if you don't count hydrogen. Hydrogen is the one weirdo. It only has 1. Now for metalloids. The best way to remember what a metalloid is like is think if metals were one parent and nonmetals were another parent and they had a baby. Well, babies tend to have traits like both of their parents, Metalloids are just like that. So metalloids are the ones right in the middle. They're the ones touching the staircase, with one very notable exception. Aluminum does not count as a metalloid, but it does touch the staircase, so be careful with that one. It's definitely a metal. For their properties, they have a little of both. They're not ductile and not malleable, sort of like their non-metal parents, but they can be shiny like their metal parents, and some of them have high melting points. We use them in things called semiconductors, so they're really good in computer parts. And the reason is because in a computer, you don't want the electricity to move through too fast because it'll burn out your computer, but you need it to move a little bit because that's how computers work. So if you have something that behaves like both things, metals and nonmetals, that's a perfect candidate. So silicon, remember right here next to aluminum, is really great in computers because it can do both of those things at once. It can either lose or gain electrons depending on where it is on the periodic table or on this little staircase, and it can have somewhere between 3 and 6 valence electrons. Now let's talk about how this looks on your backside. So you should have things color-coded similar to mine. Again, if you've left the metals not colored, I think that's the best strategy. But the thing you probably need to pause and add to your paper are the valence electrons. It was maybe a little tough to find, but metalloids are goofy. Because they have so many rings, think of the Bohr diagram, those rings start to get a little bit complicated, and they tend to misbehave. That's why they were so hard for people like Bohr and Rutherford and Thomson to sort of figure out. It took a wave model in order to get it nailed down. But they can have anywhere from 1 to 4. The point is, though, that they're all metals, and because they have relatively few, they're going to lose. And depending on what they're paired up with is going to determine how many they lose. Pause this video if you need to add anything to your paper. In Google Classroom, you will see that there is a Google Slides presentation that has the same cards that you used at the beginning of class. It looks like this. Your job is to go into this slideshow and grab the cards and sort them wherever you think that they belong now that you know about metals, nonmetals, and metalloids. Except here's the challenge. Try to do this without a periodic table. Just use the properties that are on these cards in order to sort. That is going to be the best way for you to practice. Go and do that now. If you're still watching, you have resorted your cards in the Google Slides presentation and you are ready to get a little bit more practice. Let's do a little check for understanding. You don't need to write anything down, but I'm trusting you to pause this video and actually think about your answers before you move from one thing to the next. So let's say that you have an element that's not very heavy. It's often used in manufacturing and has a very high melting point. It's conductive, and it's even sometimes used in jewelry, which means that it's malleable. Which type of element is this and why? And here's a picture of it. Pause the video if you need to think for a second. This is silver. So that would be a metal. The way that you would have figured that out is because of the high melting point. It's conductive, it's malleable, it has all the traits of a metal. Plus, if you look at the picture, it's shiny and it looks an awful lot like a metal too. The next one, you're helping with a construction project and you come across an interesting rock in the ground. When they hit it with a shovel, it crumbled into many small pieces, which means it's brittle. Your coworkers know that you're amazing at chemistry, so they show it to you. Which category is this one? Please pause and think about it. If you're ready to check, this is a metalloid. This is actually silicon. It looks an awful lot like a metal, but it is a metalloid. The dead giveaway here was the brittle part. Metals are not brittle. But this one, even though it looks like a metal, is brittle. Here's the next one. One of these elements is a deadly gas at room temperature, which means that it has a really low boiling point and melting point. Which of these 3 elements must it be? Pause and think about this one. If you're still watching, you're ready to check your answers. Magnesium and germanium are both metals, so those are not going to count because metals are not gas at room temperature. The only option that is chlorine. Chlorine is a non-metal. It has a low melting point. Next one, this material is often used in manufacturing too, but it's used in manufacturing lasers, and that's because it's a great semiconductor. It's also shiny, but will shatter when it's crushed. Which one must it be and why? Pause the video and think about it. Let's check. Aluminum is a metal. It won't shatter. Sulfur is non-metal. The only one that is a metalloid in this list is arsenic. Arsenic is actually used in lasers, even though it's super poisonous. If you've ever heard of arsenic as a poison, it used to be an old-timey poison, but it is the only metalloid from the list. Your closure for this lesson is a Google form that's in Google Classroom. Your job is to look at the description that's in the closure and choose the best material based on what you've learned about metals, nonmetals, and metalloids for something that NASA wants to prepare. So go to that in order to close out this lesson.